A number is said to be a prime number if it is divisible by 1 and itself. A number is divisible by another number if the remainder is 0 after division. For example, consider the number 7. If I divide the number 7 by 1, then the remainder is 0. If I divide the number 7 by 2, the remainder is 1. Similarly, remainder of division of 7 by 3 is 1. 7 by 4 is 3. 7 by 5 is 2. 7 by 6 is 1. 7 by 7 is 0. What we can conclude from this is a number is divisible by another number only if the remainder is 0. So from this example, 7 is divisible by the number 1 and itself. Hence, we can conclude that it is a prime number. Let us consider another example, 15. If I perform division of 15 by all the numbers from 1 till 15, I can see that 15 is divisible by 1 and it is divisible by 15. Other than this, it is also divisible by the number 3 and the number 5. Hence, I can say that 15 is not a prime number. It is not divisible by just 1 and 15, but it is also divisible by other numbers 3 and 5. Therefore, I can conclude that 15 is not a prime number. So, if I had to write a program wherein I have to check whether the number is prime or not, all I have to do is divide that number starting from 2 till the number minus 1. I can do this using a for loop. For I, starting from the number 2 until n minus 1, and I can say if the number mod I is equals to 0, if starting from 2 until I reach n minus 1, if I find any remainder as 0, I can conclude that it is not a prime number. On the other hand, if I find that num mod I starting from 2 till 14, if I find that the remainder is a non-zero value, can I conclude that it is a prime number? No. We have to check until the end before we can conclude that it is a prime number. So after the for loop completes, even after the for loop completes, if the number is not 0, then it is a prime number. We have to wait until we reach n minus 1. Actually, it is not really needed to go till n minus 1. Studies have shown that you can stop searching at n by 2. So if I want to check whether 15 is a prime number or not, I need not find the remainder from starting from 2 till 14. I can start from 2 until 15 by 2. 15 by 2 is 7. I just have to check the numbers from 2 till 7. And in between 2 to 7, if I find any remainders as 0, I can conclude that the number is a prime number. Now let us implement a program using functions to check whether the number is prime or not. So in this program, I need to read a number from the user. And then I need to check whether it is prime or not. In this program, I am expected to delegate the work of finding a prime number in a separate function. So I'll declare another function is prime. So let me write some comments about this function. The function name is prime. The input given to this function is a number and the output is 1, is the value 1 if the number is prime, and 0 otherwise. If the number is not prime, the value 0 is written by this function. So based on the input and output values, I can conclude that the return type of this function is an integer because it returns either 1 or 0. We are going to get one input to this function, that is a number, which is once again an integer. Now we need to find out whether the number is prime or not. We'll implement the logic that we have discussed previously. I'll make use of a for loop. We need to divide the number n by all the numbers in the range 2 to n by 2. If I find any remainder in this range as 0, I need not proceed further. I can directly conclude that it is not a prime number. See, we have to return 1 if the number is prime and 0 otherwise. If the remainder is 0, that means I can conclude that it is not a prime number, hence I'll return 0. Even after we reach the end of the for loop, if we did not find any remainder that is equals to 0, then I need to return 1, indicating that this number is a prime number. So this is how the function isPrime is implemented. And here in my main program, I need to call this function isPrime and then display the appropriate results. So let me declare another variable called as result, and this result will hold the value of isPrime num. I'll call the function isPrime and I'll pass the input num to it, and whatever is written, the value returned is either 0 or 1. That value is assigned to res. Then I'll check if the value of result equals to 1. The function returns 1 if the number is a prime number. So I'll write the number is prime. If not, if the result is not 0, then the number is not a prime number. Now I'll run this program. It asks me to enter a number. Let me enter the number 23. And it displays that the number is prime. Let me give another input, 34. The number is not a prime because it is divisible by 2 and 17. This is how we can implement the logic to determine whether the number is prime or not.